What is it about the Oumuamua that was so shocking for you that said, you know what, I have to invest my energies in it? What is it really? Is it an alien craft? Did you notice something different? Can you discuss with our listeners about those findings that you saw? Why did you receive so much pushback on it? And then we'll get into the, the questions about evidence and also the role of government.
Right. So first of all, the actual existence, the discovery of Oumuamua was very surprising because I wrote a paper a decade before that, which was the first paper to forecast how many rocks we should expect from other stars that would enter the solar system from outside. Based on what we know about the solar system, there were rocks ejected from the solar system, and we can do some estimates of, in total, if you assume conditions like the ones found in the solar system around other stars, how many, and we calculated that this telescope in Hawaii, Pan-STARRS, should not find any. And then Oumuamua was discovered, and it was, in order to explain it as a rock, you need an abundance of rocks that is hundreds to 100 million times more than you expect from a solar system like conditions around every other star. And so that was surprising to me. And when you realize that your previous expectation is wrong, it's an opportunity to learn something new. Actually, I'm more excited when my predictions do not come true, because then it's nature's way of telling you that you're missing something. And so still, I thought, okay, well, it's probably a rock. But the people who discovered it already pointed out in the discovery notes that they wrote that, in fact, the brightness of this object is changing by a factor of 10 as it's tumbling every 8 hours. And that implies, since we're talking about reflection of sunlight, which is simply the brightness is proportional to the area of the object in the sky that is intercepting sunlight and reflecting it in our direction. So if the object is tumbling and the brightness changes by a factor of 10, it means that the area of the object is changing by a factor of 10. And that is very unusual, because previously in the solar system, variations were up to a factor of 3. So the object must have a very extreme shape. Just think about a piece of paper tumbling in the wind. Even though it's very thin, that piece of paper, it's very unlikely for it to be exactly edge-on. So if you want the area projected in front of you of that piece of paper to change by a factor of 10, you really need it to have a very flat shape. And then there was another unusual fact about it, that and that actually convinced me that it cannot be simple, the explanation for what its origin is. And that was that it was pushed away from the sun. There was an excess force acting on it, in addition to the force of gravity. And that was a repulsive force pushing it away. But there was no evaporation. No gas was found, no dust was found around it as a result of very deep observations with the Spitzer Space Telescope. They couldn't find any carbon-based molecules around it. And usually the way that you can push an object is by the rocket effect, when it evaporates and the evaporating gases push it forward. And if they go backwards, just like a jet plane is being pushed or a rocket is being pushed. And since there was nothing evaporating from it, the question is, what is pushing it? And the only explanation that I could think of that seemed natural to me is the reflection of sunlight from it, being the force that is pushing it. But for that, the object had to be very thin, just like the example of the piece of paper we were talking about. And indeed, we are working, NASA is working on using sails, light sails that are pushed by reflecting light, and to propel an object. And so the only problem is nature doesn't make very thin membranes. And so I suggested, well, if that is the explanation, then it should be potentially artificial. So that And then on top of that, there was the origin of this object. It was at rest in the local frame of the Milky Way galaxy, which is called the local standard of rest. And stars are moving relative to that frame. The sun is moving relative to that frame. And this object was almost at rest in that frame. So the solar system was just like a giant ship that bumped into Oumuamua, which was at rest like a buoy on the surface of the ocean. And the question is, why would it be at rest when, only 1 in 500 stars was so much at rest? And so altogether, the fact that it was not propelled by evaporation, there was no jittery motion that you often see for comets that evaporate, and moreover, that it had such an extreme flat shape, suggested to me that it's not a rock. And of course, we didn't get enough data. We didn't have an image of it. But I just put forward this possibility because we have to leave it on the table. And the pushback was, of course, to say, well, it's a rock of a type that we've never seen before. And so one suggestion was that it's a dust bunny, a collection of dust particles 100 times less dense than air that are being pushed like a cloud of dust, very rarefied. And the problem is that such an object would not survive coming close to the sun because it will get heated by hundreds of degrees. Then there was a suggestion, maybe it's a hydrogen iceberg, something we've never seen, made of hydrogen. And then when the hydrogen evaporates, it's transparent, we can't see it, so there is a rocket effect. And then the problem with that is that it wouldn't survive the journey in interstellar space. So another group suggested maybe it's a nitrogen iceberg made of pure nitrogen, like the surface of Pluto, but there are just not enough Pluto-like planets to account for a large enough population of such objects, nitrogen-based. So it remains a puzzle. And obviously, cave dwellers that find a cell phone would at first think that the cell phone is a rock of a type that we've never seen before. And I'm just like the kid of the cave dwellers that says, let me look at it more carefully. Maybe, if you press a button, it might do something different than a rock. And it's just like the kid in Hans Christian Andersen's tale, who looked at the emperor and said the emperor is naked. The emperor has no clothes. And all the adults in the room said, what do you mean? The emperor has clothes. You just can't see them. And in this case, the clothes are the evaporating gases from Oumuamua.
Wow. That story is quite intriguing and also piques curiosity. And like you say, Professor, I think the biggest foundation for science is to have curiosity on our surroundings, not just, for example, this is funny, but I don't really know what a rainbow is.